Have you ever thought about the fact that we could be in a simulation right now? I think if I asked this question, most people would say yes. We've all thought about it. We've all talked about it with friends, probably when we were 14 after watching The Matrix for the first time. It's a very widely discussed topic and it's very interesting. But I think another topic that less people talk about or find themselves thinking about is, imagine we assumed that we were in a simulation. Would the physical objects around us be real? Could we say that they truly existed even though we would be part of a digital reality? Or would they not exist in the same way that objects and physical objects would exist in ordinary reality? I think this is a very interesting topic, and it's a topic that the philosopher David Chalmers talks about a lot in his book Reality, Virtual World, and the Problems of Philosophy. He believes that yes, if we were in a simulation, the physical objects around us would be real, just like the objects around us in an ordinary reality would be real. This is what he calls simulation realism, and it's what I'm going to be talking in this video. I'm going to be just dissecting one of the two main arguments that Chalmers talks about in his book, and it's an argument that relies on the nature of physical theories. Chalmers' argument on the nature of physical theories seeks to use the concept of structuralism, which I will get to in a second, to explain why, if we were in sim universe, what he calls, a perfect simulation of ordinary reality, physical objects around us would exist on par with the existence of physical objects in an ordinary universe that he calls non-sim universe. So let's get into his argument. As we can see, it has three main premises. The first one says our physical theories are structural theories. The second premise says that if we're in non-sim universe, our physical theories are true. And the third premise, it says sim universe has the same structure as non-sim universe. From these three premises, Chalmers concludes that if we're in sim universe, our physical theories are true. Let's get into the first premise first and explain what structuralism is and how it's important for our video. The more particular kind of structuralism interests us for this video is structuralism about physics. So what does that say? The approximate idea is that we can give a wholly mathematical specification of what physical theories say about the world. Look at this picture. This picture, it's a map of the New York subway systems. We can see that on the left, there are all the names of the streets and the stops, and in some way there are a lot of identities here. While on the right, all those identities are taken out, and what remains is just the logical structure of the subway system. So we see that if we packed everything into a description of the subway system and turn it into mathematics, we would have a complete objective description of the system. And by extending this process from the subway to the whole universe, we could have a structural description of all reality. Now, intuitively, there seems to be something missing. There seems to be something that is just not quite right to this, because as we saw with the subway example, where are all the identities? Mathematical structure can tell us about certain things, but it can't really tell us what kinds of things are in the world, just how many. So it feels like there's something missing. What is this thing? It's the causal structure. It's the causal relationships between entities. The point is that physical theories, they entail something more than just abstract numbers. So for something to exist, it needs to have causal power, right? So what we call counterfactuals, you can see it in all physical theories. If X, then Y. So for physical theories to be true, they need to make certain causal predictions that are then confirmed by observation, experiments, right? At least until a new experiment will falsify such theory. So the main point is that being mathematically consistent is a necessary condition for a physical theory, but not a sufficient one for the theory to be real, because it needs causal predictive power. So as we see, structuralism doesn't just entail a mathematical structure, which is the numbers you see in equations, but it also entails a pattern of relationships and interactions between the entities and the physical theories, and also a certain relationship to observation. Obviously, you need a certain relationship to experiments, to the actual physical world. So now that I've explained what structuralism is, we can go back to Chalmers' argument. And we can see that the first premise, we explain what that means. So all physical theories are structural theories. They are theories that specify a certain causal structure using mathematically specified laws and certain relationships to observation. Now the second premise is the most, uncontroversial one. It just says that in non-sim universe, the physical theories are true. So obviously for an ordinary reality, we know that the physical objects around us are real. We believe they're real. And the third premise says that the structure of sim universe is the same structure as that of non-sim universe, right? Why would one believe this? Because of course in a computer simulation, the ordinary reality is simulated perfectly within digital reality. So all the causal patterns between entities and the relationships to observation are perfectly simulated and replicated, right? So they're the same causal structures between physical objects. And the conclusion, as we said, that Chalmers gets from these three premises is simulation realism. The first premise is the one that we're going to be focusing on because it's the one that people could object to the most. The main objection to premise one that we're going to be focusing on is that the right structure just isn't enough. That even though sim-universe has the same causal and mathematical structure as non-sim universe, something more is needed. Namely, what is this? The substrate. These objections are saying basically is that non-sim universe makes certain claims about, for example, space and solidity that just are not the same in sim universe. Digital physics seems to be too evanescent, too insubstantial to truly make sure that the physical objects in sim reality would actually be real in the same way that they would be in non-sim universe. And how does Chalmers reply to this? I think it's interesting. So what he does is he starts making analogies between digital physics and ordinary physics like quantum mechanics, saying that actually in ordinary reality, so in non-sim universe, physics is also more evanescent than one might think. And that if you still accept that, and despite accepting that, you also say, okay, physics in ordinary universe is kind of evanescent. It's not as absolute and fundamental as we thought it was, but we still believe that things are real. Then you have to accept the same for sim universe. So how does Chalmers do this? We need to introduce what he calls the concept of Edenic intuition. What does this mean? He believes that Edenic intuition is kind of like the intuitive reaction that people would have to the possibility of objects being real in a simulation. This reaction would kind of mean that we believe that we are in an Eden-like world, right? That non-sim universe is kind of like an Eden-like world where there is certain intrinsic absolute properties to things, right? Solidity is absolute. Colors are kind of these intrinsic properties, and objects are laid out in space in a certain way, right? Space is absolute and fundamental. And so obviously sim universe seems to be a lot more insubstantial than that, a lot more evanescent than that. But what Chalmers seeks to prove is that actually the same can be said for non-sim universe. So actually we are not in an Eden-like universe. Science proved to us that space, for example, is not a Euclidean three-dimensional, but it's relative. Colors don't have intrinsic absolute properties, right? What we see is just what we see through perception, right? If we look at a red apple, it's not absolutely red. It's red because there are certain processes in our brain that make it appear to us red, right? But there is more to it. So science, and what he calls the scientific image, showed us that actually our world is the complete opposite of an Eden-like universe. And he seeks to make this analogy to then show that because though our objects are real despite this, the same can be said for sim universe. Now I'm going to focus particularly on the concept of space, right? I'm going to show why Chalmers believe exactly that space in like non-sim universe actually isn't as absolute and foundational as one might think within a sort of Eden-like reality. Address the first feature of space in an Eden-like universe, right? So that space is absolute. What Chalmers talks about is the fact that in our scientific world, Einstein found out, of course, that space isn't a three-dimensional Euclidean space, but it's actually relative. So it's part of a four-dimensional integrated space-time. There are no absolute squares. There are just approximate squares relative to certain reference frames. Why is this? Because of gravity, right? Imagine you take a tense rubber sheet and you draw a square on it, and then you take a heavy sphere and you put it on this tense rubber sheet. The sphere, what it's going to do, it's going to warp the square, and the square is going to become a rectangle, right? So gravity has that effect on space. That is why space is relative to reference frames, right? The second feature of space that Chalmers talks about is a bit controversial. It's the one that I find most issue with. It's about space being fundamental, right? In an Eden-like world, space isn't just Euclidean, three-dimensional, and absolute. It's also the foundational layer of reality. Like nothing underlies it. Chalmers seeks to prove that in the scientific image of non-sim universe, this could be objected against. Chalmers states, in relativity theory, spacetime at least remains fundamental, but later theories have questioned that. On some interpretations of quantum mechanics, what is fundamental is a much higher dimensional space inhabited by a quantum wave function, and our three-dimensional space is merely something derivative. What does Chalmers mean by this? It means that in most physical theory, space is postulated, right? The existence of space is assumed. What he says is that actually in a lot of more recent theory, space would actually seem to be derivative of a theory. So it's almost like, to put it simply, in very simple terms, you would almost like to prove that space exists and postulate that there is other higher dimensional kind of space that underlies the space that we have in our current reality. The problem with this claim that Chalmers makes is that it's highly speculative. Einstein proved that space is relative and it's not absolute. However, there are currently no theories that prove that space is not fundamental, that space can be derivative of physical theories. To kind of make you understand better what he means by these theories, I don't know if you watch Interstellar, but it's a theory that Murphy proves at the end, where she takes the papers and she throws them out. It would be amazing if we had that theory and we could actually prove that space isn't fundamental, but for now, they're all just speculation. So if you do believe that our space is foundational, that there is nothing that underlies it, then Chalmers' argument would not work for you. But if you do believe in the possibility that our space in non-sim universe is not actually foundational, and you still accept the fact that physical objects around you are real, then necessarily you would also have to accept that in sim universe, in a digital reality, even though space might not be foundational, right? There might be a meta universe that underlies the digital space that you see. The digital objects would still be real. Why is this exactly? You know, if we're talking about non-sim universe, why is it that even though we realize that space and in general things like color, solidity aren't what they seem, or where they would seem like in an Eden-like universe, why is it that we still consider them to be real? This is because of functionalism. Functionalism is kind of like a subsection, if you want to say it, of structuralism, according to which a phenomena can be described according to the role that it plays, right? Space might not be absolute or fundamental, but that does not matter for it being real, as long as it plays the space role. And if you accept this, then the same logic applies for sim universe. Space might not be foundation, might not be absolute in the same way that it is in ordinary universe, but it plays the same role. So you have to accept the physical objects around you in a sim reality still exist. Remember, we were talking about the first premise in Chalmers' main arguments, namely that physical theories are structural theories. And we said that the main objection that could be posed against this premise is that sim universe, to truly replicate non-sim universe, the right structure just isn't enough. So that basically a physical theory that is complete and fundamental in non-sim universe would be incomplete and not fundamental in sim unit. But what Chalmers showed is that the same could be true with some non-sim universe, right? That there might be many more levels of physics underneath the physical theories we're familiar with that we don't know about and perhaps never will. Of course, as I said, you don't necessarily have to believe this. You don't have to believe that space is derivative in ordinary reality. But if you do believe it and you agree with Chalmers that that is a strong possibility, then you have to agree with him on this too. That even though there might be a lot of more levels of physics underneath the one that we're used to in non-sim universe, it doesn't mean that the physical objects around us aren't real, and that physical theories aren't real. And necessarily, if you accept that, you have to accept the same thing for sim universe. Once we reconceive space as whatever plays the space role, so what we talked about with functionalism, then there would be room for space in those physical theories, and there's also room for space in a simulation, right? Because they play the same roles, and that is enough to accept that in sim universe, the physical objects around you would also be real. And so that is necessarily enough to accept Chalmers' conclusion, namely simulation realism.